In this video, we'll learn the rule for conditional proof. Instead of starting with this schematic like we did for the 5 basic inference rules, let's start with an example. So notice that the argument we're given, the premises are 2 conditionals, and the conclusion that we're asked to prove is also a conditional. Let's put this one in concrete terms just to make sense of it. This is like arguing, if it's raining, then the streets are wet. And if the streets are wet, then the streets are dangerous. Therefore, if it's raining, the streets are dangerous. So what we're asked to prove is that this conditional follows from these other 2 conditionals. Whenever we want to prove or infer a conditional, whenever we want to get a conditional on a line, either for some other reason or because it's the conclusion we're trying to derive, we can use conditional proof. It's a rule for getting a conditional, like if R then D. And here's how it'll look. I'm going to make an assumption. And I'm going to draw a little line to set off that I'm about to make an assumption. I'm going to assume the antecedent of the conditional. And I'm going to justify this, sort of. I'm just going to say, hey, this is an assumption. ACP stands for Assumption for Conditional Proof. Now, assuming that R is true, what follows? So I'm sort of like tentatively adding this as an additional line to my proof, but I'm marking it off as noting that it's merely an assumption at this point. So if this is a new line in my proof, I have a conditional on line 1, and my assumption is the antecedent of that conditional. So I can use modus ponens to get the consequent on its own line, and I'll cite lines 1 and 3 modus ponens. Now I have the antecedent of the conditional on line 2 on its own line. So I can get D using lines 2 and 4 modus ponens. Now I have shown that if R were true, then I could derive D. And notice my conditional is if R, then D. If R were true, I could derive D. So I've shown that D follows from R and the premises I was given to work with. So I'm going to close off this little box, which I'm going to call a subproof. And immediately on the next line, I will put the conditional, if R then D. And what I want to highlight here is that, let's pick a new color. So what I'd like to highlight here is that the assumption I made is the antecedent of a conditional I want, what I'm trying to prove. And the last line of my subproof is the consequent of the conditional I'm trying to prove. So whatever I put on the next line is going to be a conditional, and the first part, the antecedent, will be the assumption for conditional proof, and the second part, the consequent, will be the last line of my subproof. So basically what I did was I showed that if this is true, it follows that D, so I conclude if R, then D. And notice a conditional includes a big if. I'm not saying R is true, I'm saying if it's raining, if. So this is the basic sort of idea behind a conditional proof. So let's actually look at the schematic and some of the more carefully stated rules for using a conditional proof. Okay, so here's the schematic. Let's talk about the schematic a little. 1, what are these lines, or these little dots here? So the idea is that you can start a conditional proof anytime. It doesn't have to be the first thing you do in the proof, it doesn't have to be the last thing. You can start a conditional proof anytime, just like you can use modus ponens anytime. So once you decide that you want to use conditional proof because you've decided there's some conditional you need to derive, then you start a new line, n in this case, and we draw this little arrow to box it off. We indent it and use an arrow, and the point is to highlight, like visually, that we're making an assumption. Everything else is assumed to be true for the sake of argument, and now here's a new assumption, and phi, because phi could be any statement, not necessarily an atomic statement. Now every line in our proof needs a justification of some kind. What we write here is just, hey, this is an assumption. Assumption for conditional proof. Now, what statement should you put here? That's usually the most difficult task in using conditional proof. It could be any statement. There's no rule about which statement can be the first line of your ACP. But there is a statement that is strategic for you to pick as your first line. And so the ACP should be whatever you want. Like, okay, not anything, but you presumably are beginning to do in a conditional proof because there's some conditional you want to derive. Maybe the conclusion of your proof is a conditional. If the conclusion of your proof is a conditional, maybe that's why you're starting a conditional proof, in which case you would make the first line the antecedent of this conditional you want. But that's not the only reason you might want a conditional. Maybe you're doing a proof that looks like this, say, and has some other stuff in it too. And you notice, hey, here's an antecedent that's a conditional. If I had this conditional, I could get not R, and for some reason I want that. So anytime you think to yourself, I want a conditional, I want this specific conditional, that's a reason to use a conditional proof. It's a way to derive a conditional. And once you know which conditional you'd like to have, you know what to do when you're choosing your ACP. You have no business beginning a conditional proof if you don't already know which conditional you want, because otherwise there would be no reason to pick any particular ACP. So once you know what you want, you also know what your ACP is. It's the antecedent of the conditional you'd like to prove. Now, you can end your proof at any time. There are no constraints on what the last line of the proof can be. Wherever you end, your conditional will be whatever the ACP was as the antecedent and whatever the last line happens to be as the consequent. So you can end a CP proof whenever you want. But when should you end a CP proof? That depends on which conditional you're trying to get. Ideally, you'll end the CP when you've got the consequent of a conditional you want on the last line. Okay, so whatever you end up with on the last line here, you'll have to justify it, and that'll be different in every proof. Once you are able to get the consequent of the conditional you want on the last line of a proof, or just on any line, that's when you close it off and you make it the last line. So once you've derived the thing you want to be the consequent, you close your subproof. And then, immediately after you've closed the subproof, the next line has to be the conditional whose antecedent is the ACP and whose consequent is the last line of that subproof. The other thing you're going to want to do is justify this line. You're justifying putting this conditional on a new line. And the justification will be everything in this box. So if it's lines 2 through 5, that's what you'll cite. all of the lines that are in that box, and the rule is called conditional proof, or CP. Now, there's one last important rule. Whatever you've derived inside of this conditional proof, once you have closed off the proof and put a conditional on the next line, and you move on, maybe this is the last line of your proof, maybe this is a conclusion and you're just done, or maybe it's not and you have more proof to do. Once you've moved on after closing that subproof, you cannot cite anything that's inside of it anymore. Once it's closed off, nothing inside can be touched. Why? Because everything you derived in here depended on an assumption we don't know is true. And the thing that we concluded is a conditional which includes an if. It's only if that assumption is true does this follow. So we can't depend on anything that's in there except in this conditional way. So later on, this stuff is off limits once it's closed. The only thing you get out of doing a subproof is this one conditional. Okay, so let's look at some examples. Okay, let's take a look at this argument. So I recommend pausing and giving it a shot. Even though we've barely started looking at conditional proof, it's worth giving it a shot and seeing where you get stuck. That way you'll know what to pay attention to when you're watching it. Okay, so how to think through this. This is a case of conditional proof, and we know that because I picked it in the conditional proof lecture. But let's think through it strategically. The most difficult part of a conditional proof is knowing which conditional you want. That's always the most difficult part. So let's think through this strategically to illustrate how you identify which conditional you want. Our conclusion that we want to prove is X. The first thing I'm going to do is look in the premises to see where X is. X is the consequent of a conditional. The rule that lets me get the consequent of a conditional on its own line is what? Modus ponens. So if P then N, I could use modus ponens to get X by lines 3 and whatever this ends up being. So that means I want the conditional if P then N. So now I'm going to look at my premises, and it's not just immediately available there. It's not like P then N is already on its own line or something like that. And it's not, say, part of a conjunction and I can just simplify it out. I mean, it could have been like that, but it doesn't look like I can just have P and N pretty much ready to go. So what I find myself thinking is I want the conditional if P then N. Whenever I want a conditional, I think conditional proof. So that's my plan. I'm going to use conditional proof to get if P then N, and then modus ponens to get X. So what I'll do is start line 4 by opening up or starting a conditional proof. Remember, it's important to indent. We will make our first line the antecedent of the conditional we want, which is P. Remember, the conditional we want is if P then N, and we'll call that our assumption for conditional proof. Now, I like to sketch in my proof so I know where I'm going. In this case, I know about how long it'll be. Sometimes you don't know how long it will be. I recommend not worrying about wasting paper and just sketch in. I don't know how long this proof is going to take, but I know that I want the last line to be N, the first line to be P. I don't know what justification I'm going to use, but it doesn't matter for now. And I know that the minute I finish this proof, the minute I manage to derive N, my next line will be if P then N, and the rule I'll use is CP, and I'll have to cite it, but I don't know what I'll use yet. And then once I have that, I can use, this is the antecedent of the conditional on line 3, so I can use MP to get my final conclusion. Okay, so that's my big plan sketched in. But let's look at line 4 again. I've got P to work with. Now what do I do? Well, P is the antecedent of the conditional on line 1, so I can use modus ponens to get Q. Now I have the conditional on line 2 to look at, and line 5 is the antecedent of that conditional. So I can put N on a new line. Oh wait, that's what I was trying to do all along. So I'll just, don't worry about the big gap in the proof, it doesn't matter. I'll just make this line 6, and now I know what that justification is. It is lines 2 and 5, modus ponens. My next line is the conditional now that I managed to derive N. So we'll call that line 7. And I'm going to cite everything in the box, which is lines 4 through 6. My next line is line 8. 7 is the antecedent of the conditional on line 3, so I can use modus ponens to get X. And this proof is complete. Let's do one more. Okay, so here's a fun one. Again, I think you should pause the video and try it on your own, but also know that this one is, I think, a little bit difficult. So, how to get started. Let's practice reasoning backwards strategically. So, ultimately, we want Q. Where is Q in our premises? Q is the consequent of a conditional on line 4. So I'm thinking modus ponens, because that's the rule that allows us to get a condition, the consequent of a conditional. That means I need A, so I'm going to keep track of my strategy. I need A. How can I get A? Well, where is A in the premises? A is up here on line 1, and in particular, it's part of a disjunction. It has two parts, and A is part of one of those parts. So if I could get one of those parts on its own line, then I could use the simp rule to get A, and then modus ponens to get Q. So my question now is, how do I get A and B? Well, A and B, if I could get it, we see what to do, but how do I get it? It's part of a disjunction. What's a rule that allows us to put a disjunct from a disjunction on its own line? DS. So if I'm going to use DS to get A and B on its own line, what does that mean? That means I need the negation of that other disjunct. In this case, the negation of this disjunct. So that means I need if X, then Y. So if I had this, if not X, then Y, I could use DS to get this. So how do I get if X, then Y? I look at what I've got to work with, which the only two premises I haven't used yet are these two, and I see that X and Y are in there, so it looks like maybe they're relevant, but the main thing I know is that what I want is a conditional. So that says to me that I'm going to need to do a conditional proof, so I'm just going to remember that what I want is this particular conditional, and I'm going to get started with a conditional proof. So again, we'll indent, we'll make the first line the antecedent of the conditional we want. Our justification is ACP. We could sketch in where we're going, which is Y, and on the next line I will immediately put the conditional if X then Y. Looks like I'm going to run out of space. Let's do something about that. Okay, so we've made this assumption on line 5 to, where did all this other stuff come from? Well, that's weird. I guess we'll just try to make the space work. And write a little smaller. Okay, now that we have x, what can we do with it? And in particular, we're trying to get y on a line. So how do we move towards y? Y is part of a disjunction, so if I had not f, I could use ds to get y. And not regular f is the antecedent of a conditional, so I'm thinking modus tollens will get me the negation of that antecedent, which means I need the negation of the consequent, which is x, which is what I have, so that works out really well. So what I have is a conditional on line 2 and the negation of the consequent of that conditional on line 5, which means I can put not f on the next line, citing lines 2 and 5 modus tollens. Now that I have not f, I have the negation of a disjunct over here, which means I can put the other disjunct on a line, and I'll cite 3, 6 ds. Now I got the consequent of the conditional I want on the last line, so I'm going to close up shop here, fill in the box. Immediately on the next line, I'll write if x then y, and I'll use lines 5 through 7 CP as my justification. Okay, I got this conditional, and remember why I wanted that conditional was because it is the negation of one of the disjuncts on line 1, which will allow me to get that other disjunct by using ds. So let's do that. Why do I want that? Well, recall, ultimately we want q. Q is part of a conditional. If I had a, I could use modus ponens to get q, and that's why I want this. So let's simplify out this a. And then use modus ponens. And that completes our proof, which was really fun. So, at this point, you should go to the online practice. Section 3 of the online practice has lots of conditional proof practice. As usual, the solutions pages are available. You should practice doing the proofs without looking at the solutions and then look at the solutions to get feedback on how you're practicing, and don't hesitate to ask questions should you have any. I recommend going on to do this practice before moving on to indirect proof, but you don't have to master it before you move on, but I would at least get comfortable with it before moving on.